This is the third video for the ROS tutorials. Today I am going to be going through the different services. So I'm on the Understanding ROS Services and Parameters video, and let's go from there. Well, I seem to be having a display issue. Let's see if I can fix that. All right, let's go from here, and I'll just check it on my phone while I run through this stuff. This tutorial is going to be looking at the Understanding ROS Services and Parameters tutorial. Here we're going to be looking at how we can interact directly with our nodes by basically sending commands and whatnot. So, okay, my video is cropped like it's not supposed to be, but that's okay. I'll deal with it, and I'll keep it up here. So the first couple of things we're going to do, we're going to look at the ROS services. So here, as it says, services allow nodes to send a request and a response. So this is if you think about like a web HTTP or a RESTful service, I'm going to tell a node to do something, and then I'm going to get a response back from that node with some sort of status, I guess. So we have our turtle. Let's see, we can't see the turtle. Let's move our turtle up here. We have our turtle from before. I'm trying something different this time to get rid of the video issues I had last week. So in this video here, you can see I have ROS core running. This is the main core service, so I can run my other nodes. Here I have my turtle node running, so this is the turtle simulator node, and here I have a new window that I can do all of the interactions that the video says. So the first thing we're going to do is ROS service list. So ROS service list, it's going to show us a list of available services at the time we run it. So right now we see we have a clear, kill, reset, ROS out, get loggers, set log level, spawn. Then we can interact with the actual turtle by doing teleportation, absolute. I don't know what set pen is. Maybe we'll see that. I wonder if pen is like a geofencing kind of thing. Then we can do logging for the turtle. So the tutorial has us doing ROS service. Let's see what type the clear service is. So oops, wrong window. So we'll do that. We'll run ROS service type and then clear. Okay, so it takes an empty parameter. This service is empty. That means that when the service call is made, it takes no arguments. It sends no data when making a request and receives no data when receiving a response. Let's call this using ROS service call. So here, I want to show you the turtle because I think it does something with the turtle. There's my turtle. Can I see both? There, now we can see both. So if I do ROS service call clear. Okay, we didn't really see anything because our turtle is still sitting right here. This does what we expect. It clears the background of the turtle sim node. Now we're going to do ROS service type of spawn. Let's look at a case when the service has arguments by looking at the information for the service spawn. So I'm going to do this in two parts. On Linux, this pipe means take the output from this ROS service call and pipe it to ROS serve show. So I'm not sure what that does. So let's call one at a time and see what happens. So I guess there's a type of turtle sim /spawn. And let's see what ROS serve show does. Nothing by itself. Oh, can I not kill it? Control C seems to not be doing anything. But now next call, I'll if this ever finishes, I will call them in sequence like they suggested. And I probably should have done that in the first place. Can I background it? Let's kill that. Kill 29342. I'm sure that's fine, right? All right, here we'll pass it in as they wanted us to. And now we get the output. So we see that basically the turtle sim spawn command takes 3 floats, x, y, and theta, and a string name, and it's going to return a name. So here, let's do it. Let's call ROS service call spawn 2202, and I guess no name. I'm going to give it a name because I like naming things. So we'll go here and we'll call it Chris Turtle. Oh, it did not like that hyphen, so I'll do an underscore instead. Chris Turtle. So it returned Chris Turtle. And now you can see over here, I have 2 turtles. So maybe we can do another one. Let's do a 4-4. 4-4. Chris Turtle. It didn't tell me to do this, but I wanted to. Look, I have 3 turtles now. Now our turtle sim looks like this using ROS param. So ROS param allows you to store and manipulate data on the ROS parameter server. The parameter server can store integers, floats. There we go. I can read it better. Integers, floats, Boolean dictionaries, and lists. ROS param uses YAML markup language for syntax. In simple cases, YAML looks very natural. 1 is an integer, 1.0 is a float. The word 1 is a string, true is a Boolean. 1, 2, 3 is a list of integers, and that's a dictionary. A equals B, C equals D. ROS param has many commands that can be used on parameters as shown below. Set, get, load, dump, delete, and list. So let's start. We can do ROS param list, if I knew how to spell list. And we can see our background BGR. I'm assuming that those are going to be colors. Background blue, background green, black, background red, ROS distro, ROS launch, ROS version, and run ID. So the first thing they want us to do is a a set of our background R, but I want to get it first. See, I don't follow instructions very well. Background R. So the current value is 69. So we can do ROS param set background R. This is going to be the red channel. So, computer graphic colors are red, green, and blue, RGB. And it wants us to change it to 150. So when I press enter, this should turn a little more purple. Did that turn more purple? Maybe 200? Doesn't really seem to be changing color to me. Seem to be changing color to you? Let's go back to the instructions. This changes a parameter. Now, see, read instructions is good. This changes the parameter value. Now we have to call the clear service again to make it actually work. There, it changed colors. So I'll change it back to what the tutorial said, the 150. I'll clear. I wonder what happens if I turn it to 0. So there will be no red. That's blue. All right, back to 150, back to the clear. Now we got our purple. Okay, great. So here's the example. Now we'll do the green. ROS param get background green. What did I do wrong? Oops, ROS param is one word. 86 is our green. 86 is our green. Oh, now we can get slash to show us all of them. So let's do get slash. And I get background blue, 255. Green is 86. Red is 150. Distro is lunar. ROS launch version 136. Run ID is a GUID. Okay, now we can do dumps and loads. So let's do a ROS param dump params.yaml. So it's going to dump everything out to that params.yaml file. And just let's cat it out and see what's in it. It's exactly what we expected. So when I reload this, I can reload this as YAML, I guess. You can even load these YAML files into a new namespace. So, okay, so we're at the root before. So we can do ROS param load params copy. And now we can do ROS param get everything. And so you'll see in here, do I have copy? Oh no, yeah, so there's my copy. So copy has background B. So it basically moved it down a node or into a namespace. It was at a previous top level namespace, and it moved all those values into a copy namespace. Okay, that's pretty cool. So in here, what they said, now I can do this namespacing of ROS param get copy. Oops, there we go. Copy background B, and it gets exactly what we would expect. So the colors of the canvas here are not using the copy. So I betcha 255. So if I do, I'm going to set this to 0. This won't affect anything. So I'm going to set the copy background B to 0. Find my clear. There's my clear, and I am guessing that nothing will change. Nothing changed as I expected. But if we do regular root background B, then it'll change to a very ugly color. So let's get that back to 255, clear it again, and we're back. So that was a quick one today, and I'll do more next time. So thank you very much for watching, and I hope you find the other ones and enjoy it. So until next time.